Good day, everyone. Today we're going to tackle various teaching methods and instructional strategies that can enhance student learning. Effective teaching methods create an engaging classroom environment that could cater learning needs and improve student outcomes. So, throughout this presentation, I will provide classroom based examples to illustrate the application of these strategies. Traditional methods remain fundamental in education. So, the lecture method involves direct instruction where the teacher explains concepts. For example, in a science class, now the teacher will use a lecture to introduce the periodic table before moving on to interactive discussion. So, the demonstration method is useful when showing experiments like illustrating chemical reactions. Lastly, the recitation method reinforces learning, such as when the students will be asked to recall the steps of photosynthesis to ensure comprehension. For example, a senior high school class on physics, like the topic, supposing it's Newton's laws of motion. So, in the lecture method, the teacher will begin with a PowerPoint presentation explaining the three laws, that's defining key terms and providing real life examples. So, in here, students will just merely listen while taking notes. For the demonstration method, to illustrate for example, the concept of inertia. The teacher places a coin on a piece of cardboard covering a glass and quickly flicks the cardboard away, making the coin drop into the glass. So in here, students observe the demonstration and take notes. For the recitation method, after the demonstration, the teacher will ask the students to explain why the coin dropped into the glass. That is reinforcing their understanding of Newton's first law. So in here as well, the teacher will call on students to answer additional conceptual questions about the other laws. Active learning strategies engage students more deeply. So, for cooperative learning, it involves teamwork in which students will be engaged in group projects, for example, in ecosystem preservation. For problem based learning or PBL, it allows students to solve real world issues like designing an energy efficient home. In the inquiry based learning, it encourages students enhance their curiosity. It is where students now might research how climate change affects their local environment and present their findings. So supposing in the biology class, in which the topic is ecosystems and food webs. So for cooperative learning, the teacher might divide students into small groups, and each group is assigned a different biome. Example: rainforest, desert, and ocean. So they will be working together to research and create a food web diagram, which they will present to the class. For problem based learning, the teacher will present real world issues. That is, for example, deforestations, that's impact on biodiversity. Students will brainstorm solutions in groups, researching and proposing conservation strategies. For inquiry based learning, teachers here will encourage students to formulate their own questions about human impact on ecosystems. So they will be designing many experiments or research projects to investigate topics such as pollution effects on plant growth. Technology is revolutionizing education. So it is very prominent now that teachers will be using technology in the classroom. So for blended learning, it combines in-person and online resources. So posing, for example, an interactive simulation to visualize DNA replication. So a flipped classroom approach allows students to watch pre-recorded lectures at home and engage in practical applications in class. Then we have here gamification such as using quiz apps like for example Kahoot, in which it motivates students to be interactive despite holding online classes. So specific example in a DNA replication topic no, for grade 11 science class, in which a teacher here integrates technology into his lesson no, on DNA replication, that is using blended learning, flipped classroom, and gamification strategies. So for interactive simulation on blended learning, before class, supposing na students will explore an interactive DNA replication simulation on platforms like um, PhET interactive simulation or Bioman biology. They will be manipulating na, the simulation to observe how helicase unwinds DNA and DNA polymerase builds the new strand. So in class, the teacher here will facilitate a discussion asking students to explain what they observed in the simulation. That is to reinforce key concepts. While for flipped classroom, there is a pre-recorded lectures and hands-on activity. So the night before students na attend the class, they will be watching a pre-recorded video lecture, just the same way as what I am providing in the class. Na? So there is the pre-recorded lecture pertaining to the topic, which will be posted in the Google Classroom or YouTube. Then students will have to take down notes and will be answering guide questions. While in the face to face class, instead of having a lecture, students will be working in small groups to construct a physical model of DNA replication. For example, that will be using clay, colored paper, or 3D printed material. So the teacher will move around, the teacher will be providing feedback and clarify misconceptions. For gamification, Kahoot na application, for example, there's a quiz competition. So to assess learning, the teacher will conduct no, a quiz using Kahoot where students will have to answer multiple choice questions on DNA replication. So in here, um, the leaderboard and the point system no, keep students engaged, and they will be discussing answers after each round. That is reinforcing no, key ideas through peer learning. Assessment is crucial for measuring learning. So that is why no, we have here formative assessment, summative assessment, no, self and peer assessment. So for formative assessment is just like an exit tickets and where no, in which students will have to write what they have learned and provide immediate feedback. For summative assessments, no, that's a final project. So for example, it could be at the end of the unit, it could be long quizzes or a final project, for example, environmental conservation for science class. That is to assess the overall comprehension. While for self and peer assessment, that is to help students reflect on their progress and improve collaboration skills. So in here, supposing now we have here a science class, grade 8 class, for example, the topic on water cycle. So a teacher is conducting a unit no, on the water cycle and incorporating different assessment-based strategies to monitor and evaluate student learning. So for formative assessment, that is continuous feedback, at the start of the lesson, the teacher will give a quick quiz. No? It could be online quiz or a face-to-face no? quiz. Then after that, that take note that is given no at the start of the lesson that can serve as a pretest. Then during the discussion, the teacher will be asking open-ended questions like, for example, how do you think deforestation affects the water cycle? Then students will provide instant feedback na, on that question, and the teacher will have to immediately correct for misconceptions. While after the discussion, no, teacher will be asking students to write one key concept that they learned and one question that they still have in mind before leaving the class. So that's for formative assessment. It is given, it could be given before the topic discussion, during the topic discussion, and right after the topic discussion. Well, for summative assessment, it is at the end of the unit evaluation, meaning it could be at the end of the chapter or it could be at the end of the unit. No? Most of the time, no, it's what we commonly call as the long quiz, or it could be the unit requirement. It can be in the form of a project or any authentic performances that the teacher will provide. So for summative assessment, at the end of the unit or the chapter, the students will be asked to have a written test, for example, that is covering definitions, processes, and real world application of water cycle, for example, if that's a topic. If it is an authentic performance or a performance task, students will create a model or infographic na explaining the water cycle and present it to the class. That is demonstrating their understanding. If the topic is all about water cycle. Then for self and peer assessment, that is all about reflection and collaboration. So after presentation, students will complete a self-assessment rubric where they have to rate their own understanding of the topic and effort in creating the project. They also do a peer assessment in which it their classmates will provide constructive feedback na based on the rubric, focusing on content accuracy, creativity, and clarity of presentation. So the teacher facilitates a class reflection discussion, asking students what they found challenging and how they can improve no, throughout the unit. So this scenario showcases how assessment-based strategies no, help improve no student learning. Hence, no effective teaching methods and instructional strategies enhance learning experiences. So, by making use of the different no, strategies and methods, the traditional, the active, for the differentiated, no, I have a separate discussion on that topic. So that's why I no longer include it in my recorded lecture now, and technology driven approaches. No, can accommodate diverse learning styles. So, as educators, it is our responsibility to adapt these methods no, to enhance, to establish a dynamic and inclusive classroom environment.